have to then understand the relationship between absolute pressure, gauge pressure, atmospheric pressure and vacuum pressure. Absolute pressure is measured with respect to complete absolute vacuum as the datum. Okay, and in another measurement, atmospheric pressure is taken as the datum, and gauge pressure is equal to gauge pressure plus atmospheric pressure is equal to absolute pressure. When it is negative pressure, that is atmospheric pressure minus vacuum pressure gives you the absolute pressure, and you know atmospheric pressure is 10.3 meters of water. Okay, and you should also know any object located below the water surface is subject to a pressure greater than the atmospheric pressure. Okay, and we'll see what the pressure at a depth h is equal to, or difference in pressure between 2 points. It is equal to gamma h, where h is the difference in height or elevation between the 2 points. If the 2 points are at the same elevation, pressure difference is 0. Okay, and the water surface is exposed to atmospheric pressure, and in one system of measurement it is taken 0. Okay, and therefore absolute pressure is equal to gauge pressure plus atmospheric pressure, and pressure corresponding pressure head is pressure divided by specific weight, and difference in pressure head between 2 points is equal to the difference in elevation between the 2 points. Okay, then now we'll see about Pascal's law. You are familiar with, I think you are familiar with Pascal's law, which states that pressure applied at a point in any direction is equal. Okay, then I will see the application of Pascal's law in hydraulic press. In one side, little effort is applied. I was used to a automobile of heavier weight on the other side. And here you can solve a problem in hydraulic car lift. I'll read the problem. In a hydraulic car lift, the input piston has radius of R1 is equal to 0.012 meter and negligible weight. The output flanger has a radius of R2 is equal to 0.15 meter. The combined weight of the car and the flanger is F2 is 20,500 Newton. The lift uses hydraulic oil that has a density of 800 kg per meter cube. What input force F1 is needed to support the car and the output flanger, where the bottom surfaces of piston and the flanger are at the same level. B part, the levels with H is equal to 1.1 meter. So use the formula which we have just now seen. F1 is F2 into A1 by A2. Radius being given, area of cross section is pi R1 square, pi R2 square, and you get the force is 131 Newton to lift a load of 20,500 Newton. If the levels with H is equal to 1.1 meter, this is the formula, and the effort to be applied is 127 Newton using the formula shown above. Then we will see about measurement of pressure. Measurement of pressure is by means of simple manometer, differential manometer, then mechanical gauges such as diaphragm gauge, deadweight gauge, Bourdon gauge, and bellows pressure gauge. Okay, now let's see about this piezometer is nothing but a simple tube. open at the top, okay, open at the top and which is attached to the top of a vessel containing liquid at a pressure higher than atmospheric pressure to be measured. And here the height through which the liquid rises is H1 and pressure is rho g H1. Okay. Piezometers are used in pipes to determine the pressure head. Then U-tube manometer, it consists of a tube bent in the form of U and manometric liquid, maybe mercury is used here. So two liquids are involved and you take the same datum in the both the pipes. Pressures are equal. Equate and you get the pressure to be measured at C B. Pressure at B is equal to, see here, pressure at B is equal to pressure at A, okay, B is equal to pressure at A plus pressure due to height of liquid H1, okay, due to liquid H1. So BB is equal to BA plus rho g H1. Pressure at C is equal to pressure at D plus pressure due to height H2 of the manometric liquid. So it is equal to atmospheric pressure at top plus rho g H2. Equate both the pressures. The pressure at the same datum, you get the pressure at the point to be measured. Okay. Now let's move to the single column manometer. It is a modified form of U-tube manometer. Due to large cross section of the reservoir, for any change in pressure, the change in the liquid level in the reservoir will be very small, which may be negligible, and hence the pressure is given by the height of the liquid in the other lymph. The other lymph may be vertical or inclined. Based on that, it is a vertical single column manometer and inclined single column manometer. See the vertical single column manometer, with the reservoir a vertical tube is attached. Okay. So for a small change in reservoir, there is large variation in the tube. And next we will see about inclined single column manometer. The inclined single column manometer is also called as micromanometer with an inclined tube, and for slight increase there is it is sensitive, there is large variation. Okay. Okay. Length of liquid moved in the right lymph, take it as L. Inclination, take it as theta. Pressure A is given by rho 2g L sin theta minus rho 1g H1. Then I have to see about differential manometer. Differential manometers are used to measure the pressure difference between 2 points in a pipe or in two different containers. There are three types of differential manometers: U-tube differential manometer, inverted U-tube differential manometer, and micromanometers or U-tube double reservoir manometer. Okay. First we will see about U-tube manometer. It consists of a U-tube containing heavy liquid. The two ends are connected to two different points whose pressure differences are to be measured. Okay. See the sketch, it may be clear. Okay. A and B are 2 points at different heights which are connected to two ends of the U-tube as per the arrangement. So here again take a datum and equate the pressure, and difference in pressure PA minus PB is equal to H1 into Wg minus W1 plus H2 W2 minus W1 minus W1 H3. So difference in pressure between two sections is given by this expression H1 into W2 minus Wg minus W1 plus H2 into W2 minus W1. Difference in pressure head may be given by this expression, that is specific gravity by specific gravity of the liquid which flows in the pipe minus 1 into H, difference in mercury level between the ordinary difference in manometer. Here again you have to find out the difference in manometric liquid level. From that, by taking a common datum and equating the pressure in both the limbs, you can find out the difference in pressure between the 2 points A and B. So you are equating the pressure at C and pressure at D right limb, and the expression is given, and you have to find out the difference between PA and PB. Okay. Difference in pressure between A and B is given by this expression W1 H1 plus H2 W1 minus W2 plus H3 into W1 minus WG. So thank you very much for listening to this topic. For further reading, you follow some of the good reference books are there.